Hi guys, this video is to go over all the different types of functions that we're going to do in Math 3. So when you see in the instructions of a practice or a classwork, it says what type of function are you looking at or name the function. These are your answer choices. So you might want to go ahead and pause the video here and draw what I have already drawn on my notes. Alright, so linear function you guys are pretty familiar with. It is a straight line. If your line has a positive slope, it will be increasing or going up. If your line has a negative slope, it will be decreasing. Anything in blue, that is called the standard form. If you change A and B, and in this example, if you change A, B, and C, it's going to change the shape of the graph. But the green one, this is called the parent function. And so every equation that I have written down in green is the parent function for that type. The parent function is the most basic, simplest equation that you can make and still be that same category of function. Quadratic. Quadratic can be identified because it has x to the power of 2. It's okay if it doesn't have an x, and it's okay if it doesn't have a number at the end. All of those things just change the way the graph looks, but it still makes it quadratic. So the parent function is y to the second power. You're going to hear the word degree come up a lot. And the degree is the highest power that that equation has. So for quadratic, the highest exponent is 2. So when your A is positive, it looks like a happy face. When your A is negative, it looks like a sad face. Some key feature vocabulary, this would be the minimum, this would be the maximum. Cubic functions kind of look like this wavy S. And so again, this is what it looks like when the leading coefficient is positive. This is what it will resemble when the leading coefficient is negative. And you can see for cubic, the highest exponent is 3. This is the standard form. The B, the C, and the D can be missing. But, oh, I made a mistake here. I mixed these up. Sorry, guys. Glad I caught that before I posted this. That's okay. But the parent function for cubic is y equals x to the third power because the highest exponent is 3. Quartic just goes the next exponent up. Quartic is when the highest power is 4. All of these together, let me use a color that's not going to blind you. All 4 of these fall into the category of what we call polynomial functions. So in this unit, we're just going to kind of be introduced to everything. We have an entirely separate polynomial unit, so don't worry if you still have questions about those. The important thing is you can match the exponent and the shape of what the graph is going to look like to the name. If you notice, quartic kind of makes this wonky W type of shape. It's almost like if 2 of the parabolas got locked in together. That's another word that we're going to go ahead and write down next to quadratic, that a lot of times we call these parabolas. So if you hear that word, it pairs with quadratic functions. All right, and then we have exponential functions. And guys, remember that you can pause this video and finish catching up what I'm writing down and then play the video again. So exponential functions. Generally, they have a number out front, and there is some base where x is the power. So this will be a number and x is your exponent. If you're using Desmos and you try to make this and you don't see this shape, then chances are you didn't put x as a power, you just put it as 2x, which would make it linear because it doesn't have an exponent. So exponential functions can be kind of identified by this imaginary line. You should kind of see, I just sketched this so it's not perfect, but this part of the graph is going super, super flat. If your leading coefficient is positive, your exponential graph will look like it's going up, and if it's negative, your exponential graph will look like it's going down. This imaginary line where it's getting flat is called an asymptote. And in order to find the range of an exponential function, you need to know what that number is on the graph. All right, so the parent function for exponential is 2 to the power of x. 1 to the power of x wouldn't give you an exponential graph, but 2 is the smallest whole number that we can use, so that's why we chose 2 to be the base of our exponential function. And you might need to write that we call that the base. All right, and again, you might want to pause the video and write down what I have drawn right now. All right, absolute value makes this V shape. And if the leading coefficient is negative, it just looks like kind of almost like an A, but it's like an upside down V. So this is the positive, this is the negative. The key thing about absolute value functions is they have to be inside these absolute value bars. And x has to be inside of those bars. Radical functions, you typically hear square root. But it doesn't have to be a square root. If I can make it a cubed root, I can make it a fourth root. It really doesn't matter. It's going to change what the graph looks like. But the important thing that makes it a radical function is that x is under this square root sign. All right, and the other thing to notice about radical functions, it does not have an arrow on both sides. So far, all of the other graphs have had an arrow on the left and an arrow on the right, which means for every single function that was on the previous page, including absolute value, your domain would have been all real numbers because you have an arrow on the left and an arrow on the right. This particular function is a square root function because that's the smallest root that we can take. This has what we call an initial point. So that's going to restrict your domain and range. Piecewise functions. We have days to go over piecewise functions. What I need you to be able to identify is the graph is literally in pieces. And the equation is multiple equations. And typically they have this big bracket to let you know that all of those, even though they're separate pieces, they still make one graph. Trig functions, there's really only two that we're going to talk about, but there's like at least 6 trig functions that exist. But we're going to be talking about sine and cosine. So you can identify them by this continuous wave pattern. In the past, I've had students mix up trig and cubic, but the difference between trig and cubic, trig, sine and cosine are kind of stuck within that boundary. They're just going to bounce back and forth between the maximum and the minimum. Cubic is going to continue down forever and ever and ever, so it has no minimum. It's going to continue up forever and ever and ever, so it has no maximum. So yeah, the middle part might look the same, but trig is never going to go past this maximum or below this minimum. All right, and then if your graph fails the vertical line test, it is not a function at all. So you can see here this vertical line passes through that graph twice. So does this one. So neither of those are functions at all. So, I mean, this one is obviously a circle. They have names, but they're not functions. All right, be sure to write down any questions you have and come to class with whatever questions and a copy of this written down.